Hi everyone, welcome back. Today is week 8 of machine learning. And after the midterm, in this second half we'll be looking at really exciting applications of machine learning, including deep learning, which forms a lot of the recent advances in machine learning. Today we're going to be looking at the first basis for that, which is the concept of neural networks, a form of ensembling that we'll learn about that stacks together simple linear units to achieve a very interesting nonlinear effect. Let's get started, shall we? But before that, let's go and recap what we learned from last time, before the midterm break. Right before the midterm break, we were exploring the idea of overfitting and underfitting and how overfitting can be addressed, especially in week 6. We saw that we could use both validation and regularization to complement and address the idea of overfitting. Specifically, when we looked at this particular formula where we're trying to estimate how badly our test costs are going to be with a particular hypothesis, we saw that was actually something that we could decompose into two components, looking at the training cost as well as thinking of an overfit penalty when the training cost does not match the test cost very well. We saw that there are two methods of addressing this, in particular regularization, where we're trying to actually change what the model is able to predict. So we're going to constrain what H can fit by applying an overfit penalty that will constrain the hypothesis region to a particular set of models that we think are better representative of what our test function might be. We looked especially at this idea of using LP norm forms of regularization, where we looked at the geometric constraints between L1 and L2. And in the post notebook, we also examined elastic net, which is a combination of both L1 and L2. The second method which we can use for helping to address overfitting is validation. And in validation, what we're doing is we're actually looking at the testing cost of the algorithm on a held-out validation set, which we're going to separate from the training set. We saw many ways of doing this, including cross-validation, which takes the entire training data set and cuts it into multiple parts, using k-1 of the parts for training and the kf1 for validation. We can rotate this several times, up to k times, and do cross-validation as a result. This week, we're going to be looking at the learning outcomes on neural networks. We're going to look at how to describe the basic ideas of what an artificial neural network, or NN or ANN, is. We're going to explain how neural networks combine linear units with nonlinear activations, and to explain the topology of a neural network. Secondly, we're going to name potential problems with using such a high-powered representation for our machine learning model. There are a couple red flags here, and we'll see what those are shortly. We're going to describe how a neural network is trained using the backpropagation algorithm, which we'll describe in the post-lecture. We'll look at neural network regularization techniques as well, in the form of weight decay, in the post-lecture. And we'll obtain practical learning experience by using PyTorch, which is a Python library which you can use in Google Colab to construct a neural network. This we'll do in the in-class session as well as post-class.